Hello, good morning, students. So, in the last class, we have discussed about the introduction part of earthquake. Now, we will see the second module of earthquake. I'm sharing the screen. I hope it is visible to you. You just drop a message in the comment box. In the module 2, we need to study the following things: the response, history, and strong motion characteristics, response spectrum, elastic and inelastic response spectrum, tripartite, that is DVA response spectra, use of response spectrum in earthquake resistant design, computation of seismic forces in multi-story building using procedures equivalent lateral force and dynamic analysis as per IS 1893. So we'll start with the introduction part. For the design of structure to resist earthquake, it is necessary to have some knowledge of ground motion. So normally what we think is an earthquake occurs suddenly, so we cannot prevent it. Yes, we cannot prevent it, but we can reduce the damage caused by it by having some earlier study about it, by studying the history behind it. From the design of structure to resist earthquake, it is necessary to have some knowledge of ground motion. During earthquake, the ground movement is very complex, producing translation in any general direction combined with rotation about arbitrary axis. Earthquake motion can be recorded in terms of ground displacement, velocity, or acceleration. Strong ground motion as the strong earthquake shake, shaking the occur close to less than above 50 km causality for. The strength of shaking involved in strong ground motion usually overwhelms a seismometer, forcing the use of accelerographs for strong ground motion accelerometers for recording. See here, when you listen to this, it looks a bit complex, but in order to explain you in a more simpler way, what I want to tell you is that yes, we cannot prevent an earthquake, but we can reduce the damage caused by it by studying the maps available, by studying the history available with respect to earthquake, by studying the tectonic plates, by studying the ground motion characteristics, because ground motion characteristics plays a very important role. And it is complex. You need a specialized person to study this ground motion characteristic. So this is the graph for displacement versus time, velocity versus time, and acceleration versus time. So the ground motion is recorded with the help of accelerometer. Now comes the question how to measure the ground motion. The ground motion is recorded with the help of accelerometers. So with the help of accelerometers, you can measure the or record the strong ground motion. When the natural frequency of the instrument is very high compared to that of vibrations to be measured, the instrument picks up the acceleration of the motion measured. So how the accelerometer calculates the magnitude and direction of an earthquake? When the natural frequency of the instrument is very high, the instrument here is your accelerometer. If its natural frequency is very high compared to that of the vibration measured, the instrument picks up the acceleration of the motion measured. See here what is happening, as it can be seen in the graph also. It's a graph of what you can say. Just I will just go back. If you see this graph, this is a graph for not only time with respect to displacement, but it is with respect to time with respect to velocity, and it is with respect time with respect to acceleration. So what is happening is, although what we are saying is accelerometers are used for measuring the strong ground motion characteristics. But in some cases, what will happen is the natural frequency of the instrument is very high compared to that of the vibration. In such a case, the instrument adjusts itself and it measures the acceleration. Now, the component of trace of acceleration is known as accelerogram. So, what is accelerogram? A component trace of acceleration is known as your accelerogram. An accelerogram is a time history of acceleration compared composed of non-periodic sequences of acceleration pulses. So what is accelerogram? Accelerogram is a time history of acceleration composed of non-periodic sequences of acceleration pulses. It shows the traces of acceleration, one as longitudinal, one as vertical, and one as transverse. So how it is showing your accelerogram or accelerometer, how it shows the reading? It is an accelerogram is a time history of acceleration composed of non-periodic sequence of acceleration pulses. It shows three traces of acceleration. It shows how many traces of acceleration? Three. One is in the longitudinal direction, one is the vertical, and another is the transverse. See here, three types of pulses it is shown. The area under acceleration pulse is a measure of vibration transmitted to the structure with foundation on the ground. So now we will study how our accelerogram works exactly. So what is happening? The area under acceleration pulse is a measure of vibrations transmitted to the structure with foundation on the ground. So what is happening? The area under the acceleration pulse. So what is calculated with the help of area under the curve, acceleration curve? The vibration transmitted to the structure with foundation on the ground. The amplitude is of the pulse is often taken as the measure of severity of ground shaking, which could be termed as satisfactory if the duration of all the pulses are similar. So how you will differentiate this earthquake is a flow magnitude, this earthquake is very dangerous based on amplitude. If the amplitude is very severe, then we termed it as what you can say. If the duration of pulses is similar, we termed it as severe earthquake. The temporary evolution of accelerogram is composed of three parts, namely rise, strong motion, and decay. So the temporal evolution of accelerogram, how it is composed? It is composed of three parts, namely rise, strong motion, and decay. The ground velocity and displacement can be obtained by direct integration of accelerogram. So how the ground velocity and displacement is calculated? By direct integration of accelerogram. Whatever values are available in the accelerogram, if you integrate it, you will get the ground velocity and displacement. So this is the graph for time versus acceleration. Now we will see what you mean by strong motion arrays in India. So what are these strong motion arrays in India? Starting from 1976, Department of Earthquake Engineering, Indian Institute of Technology, Roorkee operated a network of about 200 analog strong motion accelerogram covering parts of Himachal Pradesh, Punjab, Haryana, Uttaranchal, Uttar Pradesh, Bihar, West Bengal, Sikkim, and Northeast India. So, what is happening in case of strong motion arrays in India? Starting from 1976, Department of Earthquake Engineering, Indian Institute of Technology, Roorkee. Way back, it is almost 50 years back. What they did, they operated a network of about 200 analog strong motion accelerogram covering parts of Himachal Pradesh, Punjab, Haryana, Uttaranchal, Uttar Pradesh, Bihar, West Bengal, Sikkim, and northeastern India. So these are the regions which were covered during the strong motion arrays in India in the year 1976 by IIT Roorkee. Now, ground motion characteristics. The literature for quantitatively describing the various characteristics of the ground motion. These cover characteristics such as amplitude of motion, frequency, content of motion, duration of motion, etc. The three ground motion parameters, that is peak ground acceleration, PGA value, response spectrum, and acceleration time history of site, commonly used in the design of structure, are known as design based ground motion parameters, DBGM. So what are DBGM? The three ground motion parameters, that is peak ground acceleration PGA value, response spectrum, and acceleration time history of a site, commonly used in the design of structure. These three are combined together to form design based ground motion, DBGM. Now we will see each of them in detail. First, starting with peak ground acceleration. The PGA is a measure of maximum amplitude of motion and is defined as the largest absolute value of acceleration time history. So, how you will define peak ground acceleration? As the name itself indicates, peak means highest maximum amplitude of motion and is defined as the largest absolute velocity of acceleration time history. So, how we are defining peak ground acceleration? The PGA is a measure of maximum amplitude. The amplitude is maximum and is defined as the largest absolute value. Largest absolute value किसकी? Acceleration time history की. In your PGA, peak ground acceleration. Generally, at a distance of several source diameters away, vertical PGAs are found to be less than horizontal PGA. Though at a near source distance, it could be equal to higher than the corresponding horizontal PGA. For engineering purposes, vertical PGA is assumed to two-thirds of horizontal PGA. See here, first you need to understand what do you mean by peak ground acceleration. So how we are defining peak ground acceleration? The maximum amplitude of a motion is defined as your peak ground acceleration, or the largest absolute value of acceleration is known as your peak ground acceleration. Again, peak ground acceleration is classified into two types: horizontal peak ground acceleration and vertical peak ground acceleration. So for engineering purpose, what we are assuming, the vertical PG is two-thirds of horizontal PG. Now comes the question, what do you mean by peak velocity? Peak velocity is the largest absolute value of velocity time history. It is more sensitive to the intermediate frequency components of motion and characteristic. The response to structure that are sensitive to intermediate range of ground motion. Example, tall building, bridges, etc. So how we are defining peak velocity? Similar to peak acceleration. It is the largest absolute velocity value of velocity, velocity time history. It maximum value of velocity in the time history curve is termed as well peak velocity. It is more sensitive to the intermediate frequency components of motion and characterizes the response of structure that are sensitive to intermediate range of ground motion. So, in order to understand peak velocity in detail, what you can assume, tall buildings or bridges are there. What will happen when an earthquake takes place? These are the buildings which are more prone to earthquake. But if the peak ground velocity of the earthquake is less than the bearable peak ground velocity of the structure, so it can withstand it. Next is peak displacement. So how we are defining peak displacement? Peak displacement reflect the amplitude of lower frequency components in ground motion. See here till now what we were saying, peak acceleration means maximum value of acceleration. Peak velocity means maximum value of velocity. But peak displacement, how we are defining? It is defined a peak displacement reflect the amplitude of lower frequency components in ground motion. Accurate estimation of these parameters is difficult as the errors in signal processing and numerical technique greatly affects the estimation of amplitude of displacement time history. Last but not the least, frequency content of motion. Earthquake ground motion is an amalgamation of harmonic motion with a range of frequency components and amplitude. Several approaches have been proposed in the literature to quantitatively estimate the characteristics. Some of them are listed below. The spectral velocity of acceleration is related by SA is equal to gamma naught into SV, where SA is the spectral acceleration, SV is the spectral velocity, and gamma naught is the natural frequency. Similarly, it can be seen that shown that SV is equal to W naught into SD, where SD is the spectral displacement. So this relation is very helpful for solving the problem, the relation between spectral velocity and spectral acceleration and spectral displacement. In the first case, we are interested in calculating or formulating a relation between velocity and acceleration. SA, that is spectral acceleration, is equal to omega naught into SV, where SA is the spectral acceleration, SV is the spectral velocity, and gamma naught is the natural frequency. Similarly, one more relation SV is equal to gamma naught into SD, where SD is the spectral displacement. So these are the graphs. Now, the maximum response could be spectral acceleration, spectral velocity, or spectral displacement, either of the three. You cannot say that spectral acceleration will be more, or spectral velocity will be more, or spectral displacement will be more. The maximum response could be either of the three. The shape of response spectrum and location of peaks are controlled by characteristics of site condition, soil or rock at the location of measurement, magnitude, vertical distance, etc. So, how the shape of response spectrum and location of peaks are controlled? By characteristics of site condition, which type of soil it is, which type of rock it is, at the location of measurement, magnitude and magnetic vertical distance. It can be seen that in general, the motion of rock contains more short period content of motion compared to that in soil. So, how we are calculating and analyzing the things? It is seen that in general, motion of rock contains more short period content of motion compared to that in soil. Similarly, the response spectrum for a low magnitude event recorded at closer distance will be rich in small period of high frequency compared to a large magnitude event recorded at farther distance. This is the graph for period versus spectral acceleration. Now we will see accelerometer in detail. So what is a accelerometer? Accelerometer is a device that measures proper acceleration. Proper acceleration being the acceleration of rate of change of velocity of a body in its own instantaneous rest frame is not the same as coordinate acceleration being the acceleration in a fixed coordinate system. So how we are defining or how we are understanding the behavior or working of accelerometer. An accelerometer is a device that measures proper acceleration. A proper acceleration being the acceleration of rate of change of velocity of body in its instantaneous rest frame is not the same as coordinate system being the acceleration in a fixed coordinate system. For example, an accelerometer at rest on the surface of Earth will measure an acceleration related to gravity straight upward by definition of g equal to 9.81 meter per second. So what is happening? An accelerometer at rest on the surface of the Earth will measure the acceleration due to gravity straight upward by g equal to 9.81 meters. By contrast, accelerometers in free fall towards the center of the Earth at a rate of about 9.81 meter per second will measure zero. So it is completely opposite of it. Seismic displacement sensing accelerometer. So, what is the basic principle? How it works? When a spring mass damper system is subjected to acceleration, the mass is displaced, and this is placed of the mass in proportion to the acceleration. So, what is happening when a spring mass damper system is subjected to acceleration? Suppose your system is a spring mass damper system which is subjected to acceleration. The mass is displaced at the displacement of the mass is proportional to the acceleration. Hence, a measure of displacement of the mass becomes a measure of acceleration. See here, linear seismic displacement sensing accelerometer. This is your damper, this is your sensing mass. Is electric displacement transducer potentiometer. The main parts of seismic accelerometer are as follows. So, what are the main parts of a seismic accelerometer? Number one is seismic mass is suspended from the housing of the accelerometer through a spring. So, what are the parts of a seismic accelerometer? Number one, a seismic mass is suspended from the housing of the accelerometer through a spring. Next, a damper is connected between the seismic mass and the housing of the accelerometer. A damper is also present in between the seismic mass and the housing of the accelerometer. The seismic mass is connected to an electric displacement transducer. Transducer is also attached to a accelerometer. There are two types of seismic displacement sensing accelerometers, namely linear seismic accelerometer. Number two, rotational seismic accelerometer. So, कितने टाइप्स के एक्सेलरोमीटर है? नंबर वन लीनियर सिस्मिक एक्सेलरोमीटर, नंबर टू rotational seismic accelerometer. Both of the above mentioned seismic accelerometer work on the same principle and are shown in figure. So see here, rotational seismic displacement sensing accelerometer. So this is the figure. This is your electric displacement transducer. This is your damper. This is your spring. Now the operation, how the accelerometer works. The accelerometer is fitted on the structure whose acceleration is to be measured. First, what we will do, the accelerometer is fitted onto the structure whose acceleration is to be measured. Due to the acceleration, the seismic mass experiences a displacement, and displacement of the mass proportional to the acceleration. So, what is happening when we are calculating the strong motion characteristic using an accelerometer? First step we do is it is fitted on the structure whose acceleration is to be determined. Next, due to the acceleration, the seismic mass experiences a displacement. जो seismic mass है उसके on क्या इफेक्ट कर रही है displacement हो रहा है उसमें, and this displacement is proportional to the acceleration. How much is accelerating is responding the same way the others are also responding. As the mass is connected to an electric transducer dispenser आ गया. As the mass in concrete is displayed, the output of the transit depends on the extent to which the mass is displayed. Hence, the outputs. Wait. Hence, the output. Hence, the output of the transistor is calibrated to give a direct indication of the accelerogram. TVA spectrum. So, what is TVA spectrum? The response spectrum can be plotted with any of the three parameters: acceleration, velocity, and displacement, as mentioned above as the ordinate, and period for frequency as abscissa. So, how you are preparing your report? The response spectrum can be plotted with any of the three parameters. If you know the acceleration, if you know the velocity, if you know the displacement, you can easily plot the spectral displacement. The response spectrum can be plotted. Okay, this is over. Now, the response spectrum can be plotted with any of the three parameters as mentioned above as ordinate and period of frequency in abscissa. So you need to draw a graph of it. So in that graph, what you need care you should take three parameters are involved, only electricity, velocity, displacement, and uh, only this much only is the thing. Okay, this figure is also not clear. The figure shows a typical tripartite plot of response spectrum for two levels. It can be note. It can also be noted that from the figure that the effect of the damping on the response spectrum is addressed in the velocity sensitive region and is listed in the acceleration sensitive or displacement sensitive region. So same is your case. You are also facing the same problem as you can get the same person. This is possible due to the fact that logarithmic domain this relationship boils down to a group of straight lines. It can be seen that there are three regions in a DVA spectrum. The portion of the response spectrum to the left of the point load is equal to 0.1 second is almost constant and is more directly related to the maximum ground acceleration. Similarly, the portion of response spectrum to the right of 10-second period is mostly related to the maximum ground, which is also constant in that region. Finally, the intermediate portion is related to the maximum velocity of the ground motion. Based on the information, a three-zone model of the traffic can be postulated. The are a displacement sensitive region that is long period and accelerations as an acceleration sensitive region that is the short of period region and velocity sensitive region that is an intermediate period region. Use of response spectrum in earthquake resistant design. So till now we have understood what exactly is the response spectra and how it is working. So now we will apply this to our earthquake structures. A response spectrum method. A response spectrum method states that response displacement velocity extension of a series of oscillators of varying natural frequency theater that are focused into the motion by the same vibration or shock. So using the same email ID, you can post this also. The resulting plot can then be used to pick off the response of any other linear system given its natural frequency oscillation. One such use is assessing the peak response of buildings to earthquakes. The science of strong motion may be some values from the ground motion spectrum calculator for recordings and surface ground motion. Seismograph for correlation with seismic design. If the input if the input used in calculating a response meter state period and steady state rate is also recorded. Damping must be present or else the response will be infinite. For transient input such as seismic ground motion characteristics, the response spectrum is equal to some level of damage. It's some level of damaging is generally assumed, but a value can be obtained even with no damping. Response spectrum can also be used in assessing the response of linear systems with multiple modes of oscillation. So that was enough. Now what you have done, they have removed the bracket multi-degree of freedom system, although there are 430 students. Model analysis is performed to identify the modes and the response in that mode can be picked from the response spectrum. These peaks as responses are given combined to estimate a total weight. A typical combination method is the square root of sum of square SRS if the model frequency is not less. The result is typically different from that which could be calculated directly from an input since phase information is lost in the process of generating the response spectra. The main limitation of the response spectra is that they are only universally applicable for linear system. हमारी चाहिए response spectrum can be generated for non-linear system but are only applicable to systems with the same non-linearity. So although attempts have been made to develop a non-linear seismic design spectrum with wider structural application. The results the results of this cannot be directly combined or multimodal. So this almost completes our module 2. I will just recall you the things. So there are two types of this is our this is just now give explain. So apart from response spectrum method, time history period is also there. And in code books also there are answers available to it. How you will design a portal frame, how you will design a retaining wall that you have seen in IS for basic. Similar to the in earthquake also one code book is there, IS 134/1993 that will be provided to you at the exam hall. You have to just check it cross it if any unwanted remove is there. You just remove it. So we will continue in the next class. I hope you all are having a good night. I hope you had your dinner. So we will just recall the things from starting. So response history or strong motion characteristic response spectra, elastic modulus response spectra, appropriate response, use of non-responsive use of no use of response spectra. So how you will use this DVA in earthquake. So how you will measure all these things with the help of accelerogram. So using accelegrams, you can calculate the things. The net was not available due to which there is a problem. I hope it is sorted out now. Wait, this is not the things which we need. This is also not the things. So we will finish today. We will continue in the next class. I hope you all are having a good time. If you are facing any difficulty, you can just call me. If I'm free, I will help you.